Okay, so here we need to explain first what do we mean by a differential equation and how to find the order and the degree of any given differential equation. So, uh, so the rule is that any equation which involves any equation which involves some um, which involves a dependent variable which involves a dependent variable and an independent variable, and also the derivatives of the dependent variable with respect to the independent one, and also the derivatives of the dependent variable with respect to the independent one independent one is called as a differential equation. Is called as a differential equation. It's called as a differential equation. For example, suppose if we have the equation, suppose 2d square y by dx square plus x dy by dx minus sine x, that is equal to 0. So here it involves the second order derivative of y with respect to x. So here we can see that here x is the independent variable. X is the independent variable and y is the dependent variable. Y is the dependent variable. So this equation, we can see it involves the second order derivative of y with respect to x, and it also contains the first order derivative of y with respect to x. So this is an example of a differential equation. Uh, then how to find the order and the degree? So order of a differential equation. Order of a differential equation, it means, so it is the highest order derivative that is present in the differential equation. It is the highest order derivative. It is the highest order derivative of the dependent variable that is present, the highest order derivative of the dependent variable that is present in the differential equation, is called the order of the differential equation. Is called the order of the differential equation. Then what is meant by degree? Degree of a differential equation. Suppose, for example, we can find the order of this differential equation. So here we can see that since the highest order derivative that is present in this differential equation is 2, so here it means here the order of the differential equation is 2, since the highest order derivative of y that is present in it, that is 2. Similarly, how to find the degree of a differential equation? So degree of a differential equation. So to find the degree, so the degree of a differential equation is defined. The degree of a differential equation is defined if if the differential equation can be expressed as, if the differential equation can be expressed as a polynomial, can be expressed as a polynomial equation, can be expressed as a polynomial equation in derivatives, as a polynomial equation in derivatives. So the derivatives are y dash or and y double dash, y triple dash, etc. Where y double dash, it means, where y dash means it is dy by dx, y double dash means it is the second derivative of y with respect to x, it is d square y by dx square, and the third derivative of y with respect to x, it is y triple dash, which is d cube y by dx cube. Okay, so if the differential equation can be expressed as a polynomial equation in its derivatives, then only the degree can be told, the degree will be defined. And if not, else we will say, else the degree will be undefined, else the degree is not defined. So the rule is, so once again, so therefore the rule is that if the degree of a differential equation, if the degree of a differential equation is defined, then the highest uh, or sorry, the exponent of, then the exponent of, or the power of, or the power of the highest order derivative, the highest order derivative that is present in the differential equation, present in the differential equation is the degree of, is the degree of that differential equation. It means that, for example, suppose we have an equation which is, suppose d square y by dx square whole power 3 m- m- minus 7x into dy by dx whole power 5 minus y power 6 into sine x, that is equal to 0, plus suppose it is. So here we see, so here the order of this differential equation, order of this differential equation is 2. Since why? Since the highest order derivative that is present in it, it is 2. Since the highest order derivative is the highest order derivative that is present in it, highest order derivative that is present in it is 2. And similarly, for this, the degree will be 3. Since why? Since the exponent or the power of the highest order derivative that is present in it, that is 3. So now the degree of this differential, the degree of this differential equation degree of this differential equation, it is 3. Since why? Since the exponent or the power of the highest order derivative, that is present in it is 3. So based on these concepts, we can solve some solved examples. So suppose we are being asked to find, suppose one question is asked, suppose to find the order and the degree, if defined. Since degree is not always defined, so we have to find the order and the degree if defined of each of the following differential equations, So then the first one is that, suppose it is given dy by dx minus cos x, that is equal to 0. Okay, so then here the order will be 1. Order is obviously 1. Sorry, it is not 2. Order is 1. Since why? The highest order derivative that is present in it is 1. And the exponent of this, that is also 1 only. So therefore the degree is also 1. And in the second question, it is given, suppose xy into d square y by dx square, then plus x dy by dx whole square minus y dy by dx, that is equal to 0. So now here the order is 2. Since why? The highest order derivative that is present in this differential equation is 2. And so the exponent of, or the power of the highest order derivative that is present in it, it is 1. So the exponent of this highest order derivative is 1. So therefore the degree will be 1. And then one third question is also given. Suppose that is find the order and the degree of the differential equation, which is y triple dash plus y square plus e power y dash equal to 0, where y dash, we know y dash is dy by dx, the first derivative of y with respect to x, and y triple dash, that is, we know that is d cube y by dx cube. It means it is the third order derivative of y with respect to x. So now here we can see that the order of this differential equation will be 3. Since y, the highest order derivative that is present in it, it is 3. And the degree is not defined. Since y, it is written e power y dash. So this cannot be expressed in the polynomial equation of its derivatives. So degree is not defined here in this case, since it can't be expressed as a polynomial equation of its derivatives. Okay. Thank you.